In this video tutorial, we're going to work on conversions between pH and hydrogen ion concentration, pH and POH, POH and hydroxide ion concentration, and finally hydroxide and hydrogen ion concentrations. You need to get fluent in all of these. The letter P is just an indication that you need to take the negative log of something. So to get the pH, you take the hydrogen ion concentration, take the log of it, and change the sign. Likewise, POH would be an indication that you need to take the negative log of the hydroxide ion concentration. To get the hydrogen ion concentration, you just do 10 to the negative pH, and likewise, to get the hydroxide ion concentration, you would do 10 to the negative POH. One last relationship to keep in mind is that Kw, which is equal to 1.0 times 10 to the negative 14th at 25 degrees Celsius, is equal to the hydrogen ion concentration times the hydroxide ion concentration. So if you have one of those two concentrations, you can always calculate the other. Suppose you're given a hydrogen ion concentration of 1.0 times 10 to the negative 4th molar. If you plug that into your calculator using the equation for pH, take the negative log of that, you will find that the pH equals 4. Little helpful hint here. Whenever the hydrogen ion concentration starts with 1.0, the pH is going to be strictly what the exponent is, because the log of this number is the exponent of 10, and change the sign and you have a positive 4. Using this equation that I have up here, pH plus POH equals 14, we know that the POH will then equal 10, because 14 minus 4 is 10. The hydroxide ion concentration, if the POH equals 10, is just going to be 1.0 times 10 to the negative 10th molar. If you need to plug that into your calculator, you would plug in 10 raised to the negative POH, and then I just made it look a little nicer by giving it a 1.0. We could do the same math given a hydroxide concentration of 1 times 10 to the negative 6th molar. You try to fill in the other missing pieces, the POH, pH, and H plus concentration. In this case, I would tend to do the POH first, because that's going to come straight from the hydroxide ion concentration. Again, I gave you 1.0 times 10 to the negative 6th, so the POH is 6, and that makes the pH 14 minus 6, which is 8. Once we know the pH, the hydrogen ion concentration is just 10 to the negative pH, and since this is already a proper format, we could write it that way, or we could write 1.0 times 10 to the negative 8th molar. Notice in both of these cases, you could have relied on the fact that, in this case, hydroxide equals Kw divided by H plus. And down here, H plus equals Kw divided by hydroxide. Let's try this problem now. You should pause the recording, get your answers, then resume the recording to check your answers. To get the POH, I use the relationship pH plus POH equals 14. Taking 14 minus 7.85 gives us 6.15 for the POH. To get the H plus concentration, I will take the relationship of H plus equals 10 to the negative pH. On my calculator, I hit the second log and then enter negative 7.85 and hit enter, and I get the hydrogen ion concentration of 1.4 times 10 to the negative 8th molar. To get the hydroxide concentration, I will do 10 to the negative POH. Again, on my calculator, I will hit second log, negative 6.15, enter, and I will get a hydroxide ion concentration of 7.08 times 10 to the negative 7th molar. Note that I could also use the relationship Kw equals H plus times hydroxide concentration, meaning the hydroxide concentration will equal Kw divided by H plus. I put in the number for Kw and I put in the hydrogen ion concentration, and I get 7.1 times 10 to the negative 7th molar for hydroxide. This is a perfect time for me to talk to you a little bit about sig figs and pHs. The number of sig figs in the hydrogen ion concentration will be equal to the number of decimal places you express your pH to. The reason for this is because the exponent part in the hydrogen ion concentration translates into the number of the pH before the decimal, and the fractional part, the decimal 0.85 in this case, comes from the 1.4. That should be obvious if we were to take a look at the first examples that we did, where we had hydrogen ion concentration was 10 to the negative 4, that's hydrogen ion, and the pH was 4. This pH here came from that right there. So technically, if the hydrogen ion is expressed as 1.0 times 10 to the negative 4, then the pH should be 4.0, 2 sig figs, 2 sig figs. So the thing to remember is the number of sig figs in the hydrogen ion concentration is the number of decimal places in the pH. Let's try another practice problem. Given a hydroxide concentration of 6.28 times 10 to the negative 4th molar, find the pH and practice expressing it to the proper number of sig figs. Go ahead and pause the recording, solve the problem, and then resume the recording. There are many different ways you could solve this problem. I chose to take the hydroxide concentration and get the POH, and then from that get the pH. Now the hydroxide concentration has 3 sig figs, so I expressed my POH to 3 decimal places. Likewise, then I expressed my pH to 3 decimal places. Let's try one more problem, giving a hydrogen ion concentration of 9.4 times 10 to the negative 5th molar. Find the hydroxide concentration. I have chosen to solve this using the relationship Kw equals H plus times OH minus. Plugging in my numbers, I get a hydroxide ion concentration of 1.1 times 10 to the negative 10th molar.